Let's condense this one. We have 3 log 2 minus 2 log 5. So I just rewrote it. So what we have going on here, we have a subtraction, which is going to mean what? We're going to be dividing, and then we have numbers in front of the word log. Those numbers mean we have a what? We have exponents. So let's get rid of the exponents first. So we have log 2 to the third minus log 5 squared. Now don't worry about going ahead and simplifying 2 to the third and 5 squared. You could leave them as is right here. So to simplify this even further, we got to do what? We got to get rid of this subtraction sign. Subtraction means we're doing what? Division. So our final answer is 2 to the log 2 to the third over 5 squared. If you wanted to, you could go ahead and do simplify 2 to the third and 5 squared. You're not mandated, or it's not required that you go ahead and simplify. I'm more concerned that you can get to this point right here. Let's try this one. Log 12 plus log 7 plus 6 log 5. Okay. Plus signs mean what? Multiplication. So let's simplify these first. So we have log 12 times 7, and I close a parenthesis, and then why? Because this 6 over here, it's in front of the log. So these two are different than this part of the problem right here. So we have 6 log 5. What does that 6 mean? It means it's an exponent. So I did that. I simplified it right over here. So we have log 12 times 7 plus log 5 to the 6th power. Simplify it once more. Why? Because we want to get rid of this addition sign. So now we have log 84 times 5 to the 6th power. How did I get 84? I went ahead and multiplied 12 times 7. So my final answer here would be log 84 times 5 to the 6th power. I wouldn't expect you to go ahead and simplify 5 to the 6th. This answer right here is fine as it is. So now we also have solving log equations. So basically what we're going to be doing is we're going to be solving for x. The only difference is now we're going to have the word log in it. So you need it in the following form to solve. Log base a of x is equal to log base a of y. So what that means is you have to have log of something on one side and log of something on the other side. They both have to be the same base. So I couldn't just have log x over here and then log a of y over here. They're not the same, so you can't combine them. So you have to have they both have to have the same what? They both have to have the same basis. So let's practice. We have log 5x is equal to log 2x plus 9. They're both same base, right? Because there's nothing written right here as a subscript for log, so we know we can solve for x. So what we're going to do is basically get rid of the word log. So we're going to have 5x is equal to 2x plus 9. How do we solve for x? Well, we're going to combine like terms. So we're going to bring the 2 to the other side of the equal sign. When we do that, when we subtract by 2, we have 3x is equal to 9. X is not by itself. We got to divide by 3. When we do that, we find x is equal to 3. How about this one? We have log 4k minus 5 minus log 2k minus 1 is equal to 0. Can't do what we did in this problem. Why? Because we have minus log here is equal to 0. The logs, it has to be log is equal to log. So how are we going to do that? How can we set this problem so that we can actually go ahead and solve? What we're going to do is we're going to add this log to both sides of the equation, so that when we do that, we now have log 4k minus 5 is equal to log 2k minus 1. Now we can go ahead and combine our like terms. Now we can go ahead and say, yes, we can set 4k minus 5 equal to 2k minus 1. So we do that. And now our next step is to simplify or combine like terms. So when we do that, we have 2k is equal to 4, divide each side by 2, and we find k is equal to 2. How about now? We have log x plus log 7 is equal to log 37. You could still simplify this one. This problem, I kind of combined. I combined in this one expanding and condensing logs in addition to also solving for x. Looking at this problem right here is not, you wouldn't be able to solve for x right away because why? We have log x plus log 7. So this you can go ahead and use, you can condense it, so we could do log 7x is equal to log 37. Now this is something that we could go ahead and work with. So when we have something that looks like this, and it would only be on one side, I would only put on one side of the equal sign. What we're going to do is use our condensing laws, and we would say, well, this plus sign means it's a product, so now we have log 7x is equal to log 37. Now, since both of them are the same base, now we could go ahead and say 7x is equal to 37. When we do that, we got to solve for x, so we got to divide each side by 7. So our final answer is x is equal to 37 over 7. Now this problem over here, why did I not say, oh, I'm dividing? Because it was equal to 0. If it's equal to 0, we can go ahead and simply add this log to that side and solve it as it is. But if it's already equal to something, we can't subtract by this log on that side. So when you see it's equal to a log, use the product rule to simplify it. When it's equal to 0, if it was equal to 0, I could have subtracted by the log on both sides. So, as always, here is your pet of the day. This right here, this is Orion. Orion is 7 years old and he loves to sleep. Some daily reminders. Your incomplete work should be handed in prior to Friday. Seniors, your last day of classes is on Friday. Tomorrow, the 14th, you will have your last quiz. If you have any questions before your quiz, be sure to send me an email. Any incomplete work, everything I've already sent you all of your missing assignments, I need it in before Friday. If you have any questions, please be sure to send me an email. Have a great day, guys.